Hello, my dear students. Today I'll start Unit 2 Shear Force and Bending Moment in Beams. Okay, so before knowing what is shear force and bending moment, first you should know what is force. Okay, so forces, there are mainly two types of forces, applied and reactive forces. Okay, in common engineering usage, applied forces are forces that are directly on a structure like dead load or live load, etc. Okay, but reactive forces are forces generated by the action of one body on another and hence typically occur at connections or supports. The existence of reactive forces follows from Newton's third law. What it states? To every action, there is an equal and opposite reaction. Okay, this is about applied force and reactive forces. Okay, applied forces that act directly on the structure, but reactive forces are generated by the action of one body on another. Okay, see here, then we will see what is supports. I think all of you know about this. I no need to again explain. I just brush up. Okay, to bear or hold up a load or a mass or a structure, etc. Supports serve as a foundation or base for any structure. As the name itself indicates, it gives supports, right, to sustain or withstand weight, pressure, strain, etc. without giving way. Okay, it is a aid or assistance to any structure by preserve its load. Supports are used to connect structures to the ground or other bodies in order to restrict their movements under the applied loads. The loads tend to move the structures, but supports prevent the moments by exerting opposing forces or reactions to neutralize the effects of loads, thereby keeping the structure in equilibrium. Okay, this is mainly used to resist the movement of the structures. Okay, see, there are, all of you know, there are three types of supports, right, based on the number of the reactions. What are those? First one is roller support, and second one is hinged support, and third one is fixed support. What is this roller support? This roller support will develop only vertical reaction, that is perpendicular to plane of rollers. Here you can see this is the representation of roller support, and this is the reaction force. Only one reaction force, that is vertical, and resisting load are vertical loads. Okay, then what is hinge support? Hinge support can develop both horizontal and vertical reactions for a given inclined load, right? See, this is the representation of hinge support or pinned support, and its reaction forces are horizontal and vertical, and mainly the resisting loads are vertical loads and horizontal loads. Okay, third one is fixed support. Fixed support can react to applied load by developing vertical, horizontal, and a moment as reactions for a load. Okay, see, this is the fixed support. This is the representation, and the reaction forces are horizontal, vertical, and moments, and all type of loads, horizontal, vertical, and moments. Okay, this is about types of supports. So here you can see that suppose if it is a roller support, only vertical, that is Ry or Ra is equal to 1, then Rx is 0, horizontal reaction is 0, and moment is equal to 0. If it is a hinge support, then Rx is equal to 1, Ry also equal to 1. Number of the reaction is equal to x direction is 1 and y direction is 1, but moment is 0. If it is a fixed support, there is a reaction. There is a reaction in the horizontal direction, there is reaction in the vertical direction, and there is a moment also. Okay, this you have to remember to solve the problem. Next, we'll see what is this roller support. I have told in a brief. Roller supports are free to rotate and translate along the surface upon which the roller rests. The surface can be horizontal, vertical, or sloped at any angle. Okay, the resulting reaction force is always a single force that is perpendicular to and away from the surface. This is the roller support, and reaction developed in the vertical direction. Okay, restrains the structure from moving in one or two perpendicular direction. Okay, it restrains the structure from moving in one or two perpendicular directions. These are the some of the examples of roller support. You can see here this is used, and this is one more example. This is in the construction site. This is gate. This is also in the construction site, and here you can see the bridges. Then we'll see what is hinge support. Hinge support can resist both vertical and horizontal forces, but not a moment. Okay, it can support both vertical and horizontal forces, but not a moment. They will allow the structure member to rotate, but not to translate in any direction. Okay, pin or hinge support is used when need to prevent the structure from moving or restrain its translation degrees of freedom. A hinge is a type of bearing that connects two solid objects, typically allowing only a limited angle of rotation between them. Two objects connected by an ideal hinge rotate relative to each other about a fixed axis of rotation. You can see this is the hinge support or pin support. It develops reaction both in x and in y direction. These are the examples. You can see here hinge support, here, and this, and here also hinge support. Then we'll see what is fixed support. Fixed supports can resist vertical and horizontal forces as well as a moment. Since they restrain both rotation and translation, they are also known as rigid supports. Okay, this is fixed support, and reaction forces are horizontal force, vertical force, and even moment also. These are the examples. See, this is fixed at a point. So fixed support, here you can see fixed support, and this is fixed. It is fixed support. Okay, this wall, and it's connected by the beam. Here it is fixed. Okay. Then we'll see what is beam. Okay, beam is a structural member that is designed to support the applied load. Here, beams basically the structures whose longitudinal dimension, that is length, is too large when compared with its cross-sectional dimensions like depth and breadth. A beam is always laterally loaded, means loads are placed perpendicular to the longitudinal axis of the beam. The structural action associated with the beam is called bending. Okay, see here, this beams are not actually loaded, and even if actual loads are present, they do not contribute for beam action. Instead, they cause compression. Okay, thus beams differ from bars in tension or compression primarily due to the direction of the load that acts on them. Due to bending, what happened? Beam will deflect from their original position. The beam is perhaps the most widely used structural element. Its use is evident in all sorts of structures, including buildings, bridges, and machines. Okay, they are they are part and parcel of a big building. They rely walls from bearing loads of the superstructure. and they also beams transfer load to the foundations through columns. Okay, there are some typical names for the beams associated with technical names are there. Suppose if the beam is made up of wood, then it is called as joist. If the beam is made up of steel, then it is called as a girder. Okay, a beam made up of steel plate is a plate girder. This beam is a general name. It is used in the structure. Okay, that is laterally loaded. It resists the applied loading by combination of internal transfer shear force and bending moment. Okay, and also here. I've told this is perhaps the most important widely used structural member that can be classified according to its support condition. You can see here, this is the beam and load is acting here perpendicular to this longitudinal direction. Okay, and here this is one of the very important structural element, and buildings majority of the loads are vertical and majority of usable surfaces are horizontal. See here, you can see this beam. The load is applied here. It is distributed to the supports in this direction. Okay, these are the devices for transferring vertical loads horizontally. And the action of the beams involves combination of bending and shear. There are different types of beams. Okay, mainly it is I have not explained all those things. What is important from syllabus point of view, that I have focused more, but I'll just explain you what are the different types of beams. Okay, beams may be classified as straight and curved beam. Okay, that is one category, and it may be a horizontal or vertical or inclined beam. Then also it is statically determinate and statically indeterminate beam, and there are also other different types, that is cantilever beam, simply supported beam, overhanging beam, fixed beam, and continuous beam. Okay, here first I will just give some examples of straight and curved beam. Okay, suppose if the beam is called to be straight, means when whose axis is along or the straight line. Okay, for example, building frame, electric roll, brake lever, screw jack, handle, etc. These are the examples for a straight beam. And if the axis of the beam is curved, then it is called curved beam. For example, chain hooks, crane hooks. These are the examples for curved beams. And also horizontal beam means when the beam axis of the beam is straight and horizontal, then it is called as horizontal beam. Okay, uh, and also for example, building a frame and beams of bridges, etc. If the axis of the beam is straight and vertical, then it is called as vertical beam. For example, electric pole. You can imagine that. If the axis of the beam is inclined and straight, then it is called inclined beam. For example, ladder. Okay, so these are the important from it for you. Okay, you have to study all these things in detail. Okay, and one more type is so this is the types of beams, how they are supported. This is cantilever, and one end is fixed and other end is free. This is cantilever. This is simply supported. This is overhanging, continuous, fixed, and this is cantilever or simply supported. Okay, this is are the different types of the beams. So in the next class I will continue with the types of beams in detail. Hope all of you understood. Thank you.